Lithium batteries are perfect for a phone or a car, but the electric grid needs to store days of energy at once, and at that scale, lithium gets absurdly expensive. So engineers went looking for the cheapest thing in the world to store energy in. Here's the counterintuitive fix. Instead of storing electricity as chemistry, store it as plain heat. Run cheap solar and wind electricity through a giant heater and warm a stack of carbon blocks to over 2,400 degrees Celsius, hot enough to glow bright white. Why carbon? Graphite is dirt cheap and abundant. It holds enormous energy per kilogram as raw heat, and strangely, it actually gets stronger as it heats up instead of melting. Compare the cost of storing a unit of energy, and carbon leaves lithium far behind. Getting the energy back out is the clever part. When you need power, the blocks are glowing white hot, so you point that glow at special panels called thermophotovoltaic cells. They're basically solar panels, but tuned to the light of hot carbon instead of the light of the sun. And these cells are shockingly good. The newest ones convert more than 40% of that glow straight into electricity, beating a steam turbine with no moving parts, no water, and nothing to spin or wear out. That's the whole point. Heat is the cheapest thing there is to store, so a battery that costs a fraction of lithium for long-duration storage suddenly becomes possible. That's the missing piece for a grid that runs on wind and sun even when the weather doesn't cooperate. The hard part is obvious. How do you hold something at 2,400 degrees for days without melting its own container? The answer is exotic insulation and clever geometry, and startups like Antora Energy and Fourth Power are racing on exactly that engineering right now. For a century, we turned heat into electricity by boiling water in spinning machines. The new bet flips it, skip the machine entirely, store the energy as a glow, and let the light itself do the work.